Hello. So a guy from Instagram, Nardzari, is his name, asked me how I did this, and it's a really easy setup. So I'm just gonna show him by doing this video, and hopefully helping someone else in the meanwhile. So if this will be useful to you or interesting or anything, leave a comment, a like or something, and let's get started. I was redoing the thing, but how it works is like this. You're just gonna destroy your geometry, do some RBD stuff, and then use point deform to deform your initial points with a trick that I end up with, because normally it doesn't work, but I'm gonna show you after. And then you can subdivide, because if you do it here, it doesn't work because they are still packed or something for the RBD simulation. Um, Basically that's it. But let's see how it is done. This is maybe too complicated, so I just thought we're gonna do it another way. Okay, let's start simple. We start with a sphere. Okay, in here, normal sphere, nothing crazy. And let me just do this. Okay, maybe covering that. Okay. So we start with a sphere, and we are VDBing the sphere, like any type, any kind of. You don't need much of voxels here, whatever your geometry is. So don't worry about the number of the voxels in here. Scatter some things around it. Okay, maybe this voxels is too low actually. Maybe you should worry a bit. Okay, yeah, make it more precise. And then you use Voronoi fracture. We are not using RBD fracture material because fuck this shit. Because in here there are a lot of rules and stuff, constraints that we don't want to use. We want to do our own constraints for this kind of thing. This would be harder for anything else. So don't use it. Or use it, but knowing that it's different because of the constraint thing. So the easiest way to do that is this. I'm doing not much of a point here. You need to do a lot of points, maybe like 20,000. Let's see, maybe more than this, but for the sake of explaining that, I'm not doing that. So let's do 2,000. Let's do 1,000. Let's do 2,000. It's cool. Okay, so you Voronoi fracture your thing using this setup, easy. And you do constraint from rules. This is the first step. Okay, constraint from rules, using surface points here, because it comes like this, center of mass, and it gives you a certain constraint that you can see here, but you have to do surface for this to work as I intend that. But you can feel free to do your things here and try get a better understanding of it, or a worse one if you want if you want to. Anyways, uh let's keep it simple as it was normal. So you do RBD constraint from rules, this one, as it comes. You just need to change that to this. Okay, RBD constraint from rules, and here you're saying give some constraints to the geometry. Okay, without this you have no constraints, and if you try to do a RBD simulation without any constraints, you're gonna end up like this, like this. It's already you didn't saw that, but it was already like breaking before of it because it has zero constraints. Anyways, if you do it with constraints, which you are doing here, it ends up like this, see? So it holds itself up. Let's see that again. Bam. Okay, so that's the breakpoint here. Constraints from rule, that's it. And you are telling here, do some constraints, okay? Where? On the surface. Okay. And how big they are? How much should they search for? Any close points? Here you can choose your radius, which it's important if you do something bigger scale, because maybe you have no whites, no constraints, which you can see with whites here, which is this thing here. No. Okay. And then here you say what are these constraints about? How are they mm, op operating? Okay. So here normal RBD constraints properties. This thing here. Normal stuff. I think it's, oh yeah, I just enabled the soft version. So enable here, soft here, because if you do it hard, it's gonna do, oh sorry, it's gonna do this type of behavior. Okay, so it just stayed hard, it didn't even fletch or anything. And if you give here less strength, it should break. It didn't. Crazy. Okay. Anyways, this is the hard one. We don't want that for this thing particularly. And with the, see how it opens? With the strength here, you can choose, and you can see what kind of strength you want of your constraints. So they are trying to stay together with a power of 1. So if you make this weaker, they're gonna stay together less and be more able to get more elastic and open more opening. Okay, if you do this like 100, you will see that they are still doing the same. Okay, maybe we need more. Anyways, this is not really the point of the thing. Yeah, it's not working for some reasons. Maybe I didn't. Anyways, this was like the first part. You don't really care about that. And this I'm gonna go in deep. Oh, the stiffness of the soft. Oh, sorry, this was the glue. Should be here. Let's see. Yeah, yeah, see. Yeah, sorry. This was here. Soft, because we enable the soft constraint and the glue constraint. Soft, we just should be able to do this here. Yeah, see? And it opens up way more than it used to. Okay, anyways, so you here choose how much of the thing you should be able to. And after that, you can see here, in the bullet solver, I'm doing collision and I'm doing a ground plane. So you have a ground plane here, as you can see. So you can collide with something. And you can see here, pop, see? It's soft destroying as the thingy, as this is softening like that. Okay, so the geometry is respecting that. On the first input, you need to get with the first sphere or whatever your geometry is. The second input must be, sorry, you cannot see that here. It's strange like that. Okay. must be time shifting the first input of your bullet solver to the frame 0. Okay, so time shift to the 0 frame. I know it's weird, but you have to do it like that. It works like that. I just discovered it, I think, by myself. That was the only way to make this work. And the last is point deform. You go with this, the output with nothing else. So it's just the output. I just put this here so I can drag it around. So hopefully this is clear. And as like this, you can do whatever you want. You can even wait. Sorry, let's do this again with stiffness like 3. Should be better on the soft thing. Let's see. Yes, this should work. See how it works? Plop. And it works. And here you can do the subdivide thing, as I was saying before. And you can see that is plop. And even more than that, let's see how it, more than that, you can do like cube, for example, a cube that transforms from here to here. Oh, sorry, from 0. No, from, sorry, from here to here, exactly. Okay, and you can use this as a collider in here. You just have to go here and go to collision and get to deforming. If you don't do the deforming collision, sorry, wait, is it working? I think so. Let's see. Yes, it's working. See? Okay, because if you don't do the deforming collision and you still animate it, it doesn't work. And it works like that. See? So now you have pop deforming, double deforming. See? And that's exactly how I did. To add a layer of improvement to this thing, because maybe you want as, sorry, let me show you here. As you can see, the orange part here, I was taking that as the static part. Okay, so this was static, the orange part, and the other things were connected to it, so that doesn't move, and the wheel is connected there to the thing that doesn't move. So if you want to do that, you need to add a layer of things. And how you do that actually, like this. So you have to differentiate your two things. This is the thing that it's gonna deform. Okay, as before there was the sphere deforming like this here. So this is your deforming thing. Might be the wheel, anything you want. Okay, let's say it's my wheel. And you make a group which is called anything you want, bubble gums, whatever, you know. And here you do another group, which is the things that you don't want to be deforming, that you want to be static, okay? And keep the other things around them static. So this is the other, I just put here a sphere, but in the wheel example is the orange part, okay? So wheel thing, orange part, group, a different group, two different groups. Then you do the same thing as you did before. The only changed part is the blue one, okay? You do the same thing as you did before. Same stuff, same stuff. You just make the rules for the sphere itself. Okay, which is two spheres now, but we don't care. You make the same rules. And after that, you make another rule. You get another constraint, and this time you say This constraint is called a new constraint name, okay? And it's group to group, okay? So it's not all, it's group to group. So it's gonna connect this group with this group, which is my not moving with my moving, which is my wheel and my orange part, okay? And you say this group here with this group here, okay? Search radius, same thing as before. How much should I search? How big of a thing, okay? Uh, how is my maximum points of searching, etc., etc., blah blah blah. Same stuff. And then you say this new rules here this new constraint that I made has new rules, okay? So this constraint, new thing, has a hard rule. Rotation only. Maybe this it even doesn't matter. But anyways, just do it like this. It works. And then you go another layer of things, new thing, RBD configure. In RBD configure, you say my new group, the static one, the orange part, okay? The static thing, which for me is BB in this case. It's gonna be active, and active it comes like this normal. You go 0 and you flag it. Flag sleeping, flag enabled sleeping, 0 1. So it's 0 0 1. And this makes not the static part not moving and staying there. Okay, this makes it. Because if you don't do it like this, it's gonna go. Yeah, they both going. But if you do it like this, they do not. See? Okay. And then you can do the same things as before. You can do the box for a collision with transform stuff. And it works. As you can see here, this is static and it's keeping the other sphere to its static self. And the box is gonna collide. And it works like this. Pam 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 pam. Pam 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 pam. Boom. Static, not static. Boom. And here you can go with the same stuff as before. You take your first thingy that is deforming, point deform it, frame to 0, this to the other thing, and voila. Okay, important part here, which you can see. This is not something you want, but it happens. Even in my wheel thing, somewhere here it happened. So you must be careful about that. Somewhere here, I think it happened. I am pretty sure. You cannot see that maybe, because I was good in like hiding it properly, but this happens. It doesn't happen a lot if you have. I mean, it helps to have a lot of geometry here. Okay. And sorry, it's taking a while. Ba 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 ba. Okay. Let's see, let's see, let's see. Okay. Yes. You have to have a lot of geometry here and a lot of fucking points. Because the more you destroy this with more points. Let's see. It's taking a while. Give him like 20 seconds, maybe less. Come on, man. Come on, man. Come on, man. Holy fuck. It's taking a while. Well, it's a lot of points, so I get it. Let's see that here. Yeah, here, I think, yeah, it was, no, maybe this. Yeah, this is a thing like that. Here, too. So there is problems like that, but the more points you have, the more destroyed things you have here. The more, I mean, the more breaking parts, the more parts, the more points you have, the better it gets to the final thingy, and you have it better than ever. So that's the important part. After it, I just took a while to figure it out how to get like this, and I got a solver here to do some things, which is not the case to do this now. But uh, if you are interested, if any of you guys is interested in how to get this like visualization of the forces that are involved, of the how much is deforming every fucking part of this type of things, let me know. I'll do a video about that too. Uh, Hopefully, my friend from Instagram, this was helpful. If this was just, I don't know, leave a comment, tell me something, like anything, subscribe if you didn't already. And hopefully, this was clear and helpful. And if it's like something missing, just tell me. And I'll see you guys in another video. Bye bye. Hopefully I can bye-bye you with the full thing. No, I can't. I'm gonna bye-bye you with a sphere. Bye-bye.